So this is another probability distribution question, and what we're told is this: the weights of salads taken by customers at a self-serve salad bar are found to be uniformly distributed uh, between 250 grams and 450 grams. Write down the probability density function for this distribution. We're asked a couple of other questions as well. Find the probability that a customer will take a salad weighing more than 400 grams, and find the probability that a customer will take a salad weighing between 320 grams and 400 grams. And lastly, what we're asked is what are the mean and standard deviation of the salad weights taken by the customers. Now, first off, just as a quick remark, we're actually told explicitly that this is a uniform distribution. You can't tell otherwise from the question if it is uniformly distributed or not. There's no sort of ways you can figure it out. You have to be told explicitly that it is uniformly distributed. So as a result of that, what we're going to do is go to the back of the exam paper and we're going to look at this here. So uniform probability density function, and just as a quick remark, that's what we're being asked here. So essentially this is what we have to write out here. But what we have to do is just actually sort of figure out what the parameters are here. The two parameters are beta and alpha, or actually in fact alpha and beta. So alpha is the minimum, and beta is the maximum. Okay, and in this case alpha is 250. And beta is the maximum, is 450. Okay, so what we're going to do is actually just write this this top line out again. And uniform probability density function, for this particular example with the salad bar, we would write f of x equals 1 over 450 minus 250. We actually might rewrite that as 1 over 200 for x between alpha and beta. That is for between 250x and 450, and it is 0 elsewhere. Okay. Okay, so that one's actually straightforward enough. Actually, the thing is actually just to sort of not being too intimidated by phrases like probability density function, and also just actually so know what alpha and beta mean, the maximum and the minimum. So it's a straightforward enough question, really. What I'm going to do here, just while we have it here, is actually I'm just going to answer the last question now, because we have it right here down at the bottom of the exam at the formula sheet. Mu of x, the mean mu of x is a half of alpha plus beta. So I'm actually just going to do this here now. We'll answer the fourth one now. Mu of x as alpha plus beta over 2. So alpha plus beta over 2, that's equal to 250 plus 450 divided by 2. That's equal to 350. Okay, and the standard deviation is alpha minus or beta minus alpha squared divided by 12. Let's make a little bit of room for that here. That is equal to sigma squared is the variance. Okay, and that is equal to 450 minus 250 squared over 12. Okay, 12 is the constant in this case. So this is equal to 400 squared divided by 12. 200 squared divided by 12. And my pen is just jamming up here for a second. So just as a sort of quick remark, actually, that this here is the variance, what we're told here, but we're asked for the standard deviation. That's a little banana skin. Okay, so this is 200 squared. The variance is 200 squared divided by 12. Working that out in the calculator, that is equal to 3,333.33. But the answer we're looking for is the standard deviation is what we're looking for. So the standard deviation sigma x is equal to the square root of that, 3333.33, and that's equal to, again, a bit of calculator work, 57.73. Okay, so the answer to the mean is 350, and the answer to the standard deviation part is 57.73. Now, just remember to put in units here. So we're dealing in grams, so that's 350 grams and 57.73 grams. Okay, let's put that in there in red. So that's the first part done, and the second part. So 350 grams and 57.73 grams, and also down here we have the answer to the probability density function. Now what we're going to do here is we're going to compute some probabilities, and find the probability that a customer will take a salad weighing more than 400 grams. Well, first off, what we can find out is the probability of, we're given a formula here that we can work with, but it's the probability of x less than or equal to k, for the probability of salad weight being less than a certain value k. So probability of x less than or equal to 400 is, it's not actually what we're asked here. In the question asked is more than 400, but just bear with me for a second. That is equal to 400 minus 250 all over 450 minus 250, and that is equal to 150 divided by 200, and that's equal to 0.25. Now, just to be clear, why we done that out there in the first instance, sorry, that's not the answer. I've actually accidentally told you the answer to the full thing. So it's not 0.75. So the answer to this question here is what we're being asked. Probability of x greater than or equal to 400. Okay, it is the complement of what we've been told there previously. Just as a remark, actually, why is it the complement? Because why are these two signs complements of each other? Because uniform is continuous. The uniform is a continuous distribution. So that's why we write the complement of this as this, okay? That's a very important matter there. So what is the complement of that? That's equal to 1 minus the probability of x less than or equal to 400. And that's equal to 1 minus 0.75. And the answer to that, therefore, is 0.25, which I accidentally blurted out there a minute ago. So the answer to that one is 0.25. That's the answer to the second one. So moving on now, we're going to look at find the probability. Actually, what I could do here, just as sort of digression, is we could actually just look at the graph at the probability density curve, the density curve here. So what I'm just going to do briefly is actually just draw a curve here, and so sort of mark in a few values here. It actually just always helps to put in a bit of a graphic there, just to make sure that you can sort of follow what you're doing. Now, the uniform distribution is actually quite an easy distribution to work with, but the idea of working with the graph is actually quite important. A graph like this, a density curve, because when you're dealing with other distributions that are a bit more complicated, for example, a normal distribution, being able to visualize what you're trying to do with a graph like this actually helps a lot. Now, the uniform distribution is a sort of rectangular shape. Okay, so I'm going to put in a little bend in the curve here, just to sort of say this is it's actually not quite close to zero. It's let's do that again. It's actually quite far away from, oh, there we go. It's quite far away from the origin. So sort of way you might mark that in is just to sort of say we're sort of out a bit from the origin. So that's 250, 450. The question we just asked there previously was that compute the probability of x less than or greater than 400. So on the graph it might look like this. We're roughly about a quarter there. Okay, actually let's just mark in, this is f of x here. and that's 1 over 200. And so the next question is, find the probability that the customer will take a salad weighing between 320 grams and 400 grams. Okay, so on the graph that will look something like this. Let's say, let's put it in here. So this is 320, let's say, and this is 400. And on the graph, it is this area here. Okay. Now, the thing about it is, how do we calculate that? What we could do here is find out what this area is down here at the bottom, or down here at the left-hand side. Find out what this area is here. That area we can compute as the probability of x less than 320, and that is equal to 320 minus 250 all over 450 minus 250. That's equal to 70 divided by 200, and that's equal to 0.35. So this area over here is 0.35. Now, just as a remark, this area here, and this area here all have to add up to 1. So what is the area? What is the probability of this area here? Necessarily, it must equal to, I'm going to call this x just for a second. Let's put that in there in black. So this is x. No, I'll just actually use x. I've already used x already. So anyway, what is it actually? It is, we don't really need a symbol. It is 1 minus 0.35 plus 0.25. That's equal to 1 minus 0.60, and that means it's 0.40. Actually, you could have done that with a bit of simple mental arithmetic there, that the three areas have to add up to 1. Alright, that ends the presentation.